Welcome to The Explainer. Today we're diving into one of the most mind-bending ideas in all of science, the suggestion that just maybe the universe doesn't even exist until you look at it. Let's get right into it.
So let's just start with the big question right up front. Does the act of looking at the world somehow create it? Now this sounds like pure science fiction, but what's really wild is that for a while, even the founders of quantum mechanics, the most successful scientific theory in history, actually thought this might be the answer.
To really understand how they got to such a strange conclusion, we have to go back to the very beginning of the puzzle. It all started with the bizarre identity crisis of light itself. Was it a tiny solid particle, like a billiard ball? Or was it a ripple spreading out in a pond?
For literally centuries, scientists were completely split on this. You had giants like Isaac Newton arguing that light was made of little particles, while others like Christian Huygens were convinced it was a wave. And for more than 200 years, experiment after experiment kept proving, well, that both sides were right. And in science, that's a huge problem.
I mean, the evidence for both sides was just staggering. You had experiments like the famous double slit test, which clearly showed light behaving like a wave, creating these interference patterns just like ripples in water. But then, you had Einstein's photoelectric effect, which showed light acting like a tiny bullet, literally knocking electrons out of atoms, something only a particle could do.
So science basically hit a wall, a complete stalemate. You had major, undeniable experiments supporting the wave theory and just as many supporting the particle theory. It created this deep paradox, and physicists had to accept a really strange, uncomfortable truth. Light was somehow both, a particle and a wave at the exact same time. And right here is where the story gets even weirder. Once physicists were forced to accept that light had this bizarre dual nature, it opened up a whole new can of worms. It led them to ask an even more profound question. If light can be two things at once, what about everything else? This was the absolutely brilliant insight from a physicist named Louis de Broglie. He had this hypothesis. He thought, okay, if light can play by these weird rules, then maybe all matter does too. You know, the electrons, the atoms, the very stuff that makes up you and me. It was a bold idea, one that sounded almost absurd at the time. And get this, just 3 years later, an experiment proved he was absolutely right. Electrons, the fundamental particles of matter, behaved exactly like waves. This just created a massive, massive puzzle. It meant that at their core, things like electrons don't even have a definite location, just a blurry cloud of possibilities.
So, that leads to a pretty obvious question, right? If the entire foundation of our universe is built from these ghostly waves of probability, how in the world do they all come together to form the solid, stable, and very definite world we live in every day? Why doesn't your hand just pass right through the table?
So, faced with this seemingly impossible paradox, some of the greatest minds in physics came up with an explanation. And it was an explanation that was as revolutionary as it was mysterious, one that would totally change our understanding of reality itself.
This idea is the famous Copenhagen interpretation, and it was championed by guys like Niels Bohr and Werner Heisenberg. They came up with this concept they called wave function collapse. Basically, they said an electron exists as a wave of all possible outcomes until the moment it's observed. And that act of measurement, they argued, forces nature to just pick one single reality out of an entire ocean of possibilities.
And this is the exact origin of the myth we're talking about today. See, if observation is what causes the wave to collapse, and you need a conscious observer to do the observing, well, the logical next step seems to be that consciousness itself is the force that turns all that quantum fuzziness into our concrete reality. Without you to look at it, the world is just a shimmering sea of maybes.
But yeah, not everyone was buying it. Albert Einstein, for one, absolutely hated this idea. He found it completely illogical. He famously mocked it with this classic question to Niels Bohr, which just perfectly captures how absurd it seems that the universe depends on us watching it to even exist. For decades, this whole thing was really more philosophy than science, mostly because the technology just wasn't there to actually test it. But modern experiments have finally pulled back the curtain, and they've revealed the physical truth behind the so-called magic of observation. It turns out, decades of confusion can pretty much be cleared up with one simple change in language. The whole mystery really starts to dissolve when we stop using that vague, mystical phrase, wave function collapse, and instead use a much more precise physical term, quantum decoherence. So what does observation really mean in quantum mechanics?
Well, it has nothing to do with a conscious mind. To see an electron, you have to physically interact with it, usually by hitting it with another particle, like a photon of light. This interaction is disruptive. It's like trying to find a delicate ripple in a pond by throwing a rock at it. The very act of measuring scrambles the wave and knocks it out of sync. And that loss of sync, that's decoherence.
So let's be crystal clear. It's the physical, kind of clumsy act of interaction that makes the wave-like behavior vanish, not some mysterious power coming from a conscious mind. And this was finally confirmed with experiments in the 1970s by H. Dieter Zeh, who was able to do the kind of detector tests that Bohr and Einstein could only ever dream about.
Okay, so this brings us to the final piece of the puzzle. If decoherence is caused by physical interaction, then why does our big, everyday world feel so solid and so real all the time?
Well, the answer really starts with just sheer scale. I mean, think about something like a tennis ball. It contains an almost unimaginable number of atoms. We're talking a 1 with 25 zeros after it. And every single one of those atoms has its own wave function.
So imagine all those atoms are like dancers trying to perform a perfectly synchronized routine. But the environment, the air molecules, the photons of light, cosmic rays, is constantly bumping into them. Each tiny bump is a physical interaction that knocks one of the dancers out of sync. Now imagine that happening to quadrillions of dancers, trillions of times a second. There's just no way for them to maintain a coherent wave. All their quantum weirdness gets averaged out almost instantly.
And on top of all that, there's a fundamental law of physics at play here. The de Broglie equation basically shows us that an object's wavelength gets smaller and smaller as its mass gets bigger. So for something as massive as a tennis ball, its wavelength is trillions of times smaller than a single proton. It's so tiny that it's physically impossible for us to ever detect its wave-like nature.
All right, so we've gone on a journey from a simple puzzle about light all the way to the very nature of reality itself. So what's the big takeaway here?
The bottom line is this. The world is not some illusion waiting for your consciousness to make it real. The reason our world seems solid, stable, and definite is because of a constant, unavoidable physical process called decoherence. Countless tiny interactions on a massive scale effectively wash out all the bizarre quantum effects, leaving behind the classical, solid reality that we all know.
You know, figuring this out, demystifying one of the spookiest ideas in quantum mechanics, it really just shows that the universe is ultimately governed by physical processes, no matter how strange they seem at first. And it makes you wonder, if we solved this giant puzzle by simply redefining observation as interaction, what other great mysteries are just waiting out there for us to find the right way to look?